welcome to this person sitting over here on their own. Everybody else, for some reason, you got Coke and snacks and stuff, go for it. This is going to be very intimate, so we're going to change the format a little bit here. There's enough of you here that if you want to ask a question during this, let's do this, because I don't want to sit up here and spout to you all and then go through a question and answer session at the end. We'll stick to time because I'm the only person now between you and some beer, and we'll get started. So this is the title of my presentation in the way that it actually fits in with the template that they gave us, but as you know, this is what we're talking about. It's how to achieve continuous improvement, integration and deployment with GitHub, Visual Studio and Azure. My name's Daniel, I'm the Director of Solutions Engineering for all of APAC except for Japan, because they're lucky enough to have another office over there. And I spend an awful lot of time on a plane. So I just got in yesterday from the US. We do have a demo, but it is pre-recorded and I'll talk to that, which is much better than me typing when I'm half jet lagged. So what we're going to talk about is essentially how you can change a culture within an organization to be able to speed up how you deploy. I'm going to talk a little bit about GitHub, who we are, in case you don't know. Who here knows who GitHub is? Who here actively uses GitHub? Who here has found a solution on GitHub that they've pulled down? Did that solution get you a HD in a university assignment? Oh, damn, I've caught a few people out with that. Has anyone here contributed to open source software? Thank you. And thank you to anyone who uses GitHub. It's great. We really appreciate it. So a little bit about us, if you don't know. We're about 9 years old now. We were founded in 2008. Oh, that's a bad way to start that. We're probably about the 55th most visited website in the world at the moment. And if you consider how many websites there are out there with people doing things like personal banking and shopping and all that kind of stuff, for us to be in the top 100 as a developer tool is a pretty remarkable thing, so we're quite proud of that. We have offices in San Francisco, Tokyo, Amsterdam, and Boulder. We also have a very strong remote workforce, so over half the company works remotely, and they live inside GitHub. We don't have an office in Australia, but we do have 8 support staff, we have 3 engineers, and we have our sales guys and myself, and we're based out of Sydney, Melbourne, Adelaide, and 1 guy in Hobart. We have 20 million active users at the moment on GitHub, and we have about 3 to 3.5 million hit the site every day. There are 40 million repositories currently on GitHub. Now, out of those, I would probably say around 65 to 75% of those are actually active. The rest of them are things like my Hello World project, when you do the tutorial, when you come into GitHub for the first time, or they're a fork for a piece of software that someone's decided they thought they'd have a go at doing something with, and then they've just left it there to rot, not doing anything with it. So out of those 40 million, I would say is a good chance that anything from 28 to 32 million would be actually active at any one time right now. How many are private? I don't have that breakdown on me. Sorry. It's a good question. I should have thought about that. The question was, by the way, how many are private? I don't know. So just to make sure that we're all on the same page, what I'm going to do now is distinguish between Git and GitHub, because that does lead to a bit of confusion out there. Git, as you know, is a distributed source control management system. And the whole idea about this is that everybody has access to everything within that repository. So if I need to go work offline somewhere, I've got to spend 8 hours on the plane, which happens a lot. I can check out the entire thing. I can make changes, I can save those and commit those changes locally. And then when I land or get back onto the network, I can push those back up to the network. At the same time, there's something that we often get asked about is each of those changes, do we store just the deltas into those changes, or do we actually store the entire file? So everything we do is based around snapshots. Now this means that you can have a little bit more storage used, but to be honest, storage is one of the cheapest things in the equation nowadays. But we think that's actually a much more stable way to actually store changes to files. And the other concept around a distributed version control system is the fact that there's a remote repository that's the ultimate source of truth. Everybody pushes their changes into that remote repository, they pull out changes, they merge them locally, whatever they've got to do to work, and then distribute those changes amongst everybody else from there on in. Now, to distinguish that from us, we provide a whole bunch of services that sit on top of that. So you still use Git for your version controlling, for your source control. For GitHub, we bring all the collaboration features that we talk about there. We talk about things like issues and pull requests. We talk about things like the GitHub flow. We talk about things like integrations and so forth. If you're trying to integrate to build a continuous deployment system out of something like Git, the only way you can really do that is poll the Git repository every so often, pull down changes and run from there. It's a very inefficient way of doing things. But we add some layers on top of that, such as webhooks and APIs, to stop you having to go and constantly poll repositories, just react to events as they come up. And that also helps us with things like, oh, I've just covered that with integrations. The other thing we also do are organizations and teams so that you can more actively manage through more granular permissions who can do what within the repository. I'm going to talk a little bit about open source and I want to share some interesting information about you, especially for a Microsoft conference. And the thing is that GitHub is not just about workflow. It's about finding projects, it's about contributing, it's about getting involved with the open source community. And some of you may be surprised to know now that Microsoft is now the biggest contributor to open source software on the planet by a long shot. All right, they host open source software on GitHub. Who's used .NET Core, for example? Okay, cool. All right, largest number of contributors. C# as a language has had almost double the growth in the last 6 to 12 months on GitHub in terms of C# based repositories. And TypeScript as an upcoming language is pretty good as well, all right? Over double the growth has happened in the last 6 months. So we're seeing a real groundswell of developers from the Microsoft side of the world now come over and become part of the open source community, including Microsoft themselves. We're pretty happy about that. In fact, Visual Studio Code is now a top 10 repository in terms of downloads of github.com. So Visual Studio Code is built off the Electron framework, which is actually a framework that we provide. And it allows you to build cross-platform applications. Essentially what you're doing is you're kind of running Node.js locally on your machine with a HTML view sitting over the top. And some of the things that people have been able to achieve now by using the open source versions of, for example, of .NET, is this is an online role-playing game called Age of Ascent. And they switched over to the .NET Core that was hosted open source. And over time, as the community made contributions to .NET Core, they saw a 2,300% increase in their ability to be able to service calls in terms of the number of requests they were handling per second, up to 12.6 gigabytes per second of traffic they were pushing out, due basically through community efforts to improve software through collaboration and some automation processes that we're going to cover. In fact, even the documentation for ASP.NET Core is hosted on GitHub. So you can see if you just click on the edit button, it's going to take you to the GitHub repository. You can fork it. You can then go and make the changes that you're interested in changing and then submit them back for consideration by the .NET documentation team. And so we really encourage you to get involved in this. So thank you to anyone who actually works with us on open source software. So let's get now into what I actually came to talk to you about, and that's about automation, about how you can actually improve, have continuous improvement, integration, and deployment using GitHub, Visual Studio, and Azure. The first thing I'm going to talk about is GitHub and pull requests. And this is probably going to be the least technical part of my talk, because like I said, even though we're talking about here about improving your productivity, not all of it's going to be through tools. A lot of it's through collaboration and changing a business culture. So who here knows what the GitHub flow is? Cool, couple. All right, so I'll describe it quickly. You have one branch, it's your master branch. Now, no one makes changes to that master branch without going through a proper test and approval process. If you've got an idea for a new feature or you want to fix a bug in your product, you just basically create a branch off that master branch. You make a couple of changes, and then when you're happy with the changes you've made so far, you actually then open up the code, you actually open up what you've done to the community, the people you work with, for a discussion and approval process. And the whole idea is, and what we recommend, is that you open up that pull request as early as you can during your process. All right? Some people don't open up a pull request until they're almost ready to ship. And if they've got a deadline and then there are major problems in the software, you have issues. So what we recommend is that if you're going to be involved in a process like this, is that you make a few changes until you're comfortable with discussing your changes with your colleagues, open up your pull request, and get talking straight away. So the idea about this is so that you can experiment without risk. You may have read of a new algorithm somewhere that helps improve your search algorithm. Screwed that one up. You may have read something somewhere about something that can actually improve your search algorithms. It can, you might want to try a new feature within the product. You've seen a particular issue around a bug that you want to try and solve. And that's when you open the branch. You get to work on it. Once you want to then, like I said, discuss those branches with everybody else, you raise a pull request. And the whole idea of the pull request is to gather that feedback from everybody else, integrate with those continuous build and deployment tools that we'll have a look at in a second. And then obviously make sure that the code meets the needs of the organization. So I'm going to go through the pull request loop a little bit. I'm going to talk about what works inside of GitHub and what works on github.com as a whole. So the important thing that when you write a pull request, for example, that you're very clear about what you're trying to achieve. If you have specific references that you want to refer to, go ahead and do that. All right? When you're providing feedback, it's about being positive, right? When you're developing software, it shouldn't be a blameful environment. Human error doesn't often happen because of incompetence. It's usually because of other problems within an organization. And the only way that we can learn and grow together and produce better software is to collaborate and be more open, be not afraid to take risks, and correspondingly discuss things accordingly. If you're the person who raised that pull request and someone's provided you with feedback, please acknowledge that feedback. Provide clarifications if necessary. But the whole idea of this process is to have a positive conversation. You know, software collaborative development environments are not about trolling. They're not about trying to prove that you're the smarter person than the person who's asking for your feedback here. It's about everybody working together. So like I said, that was the touchy-feely part of the process. Let's talk a little bit now about continuous integration. So once you have people now that are openly working together, quite happy to experiment, quite happy to look at new features, new ways of doing things, how do you then ensure that you can then get those changes into production as quickly as you can? And one of those things that will help you there is continuous integration. Does everyone know what I mean when I talk about continuous integration? Does anyone need me to explain it? Good. All right, awesome. So what you can then start doing is, like you're saying, is automating all those builds and tests that you need to do, the stuff that really drags you down. All right? And by doing that, you then focus on the quality of your software, you focus on that collaboration that is happening and so forth. Once all the boxes are being ticked by your continuous build environments, and obviously you can merge that code back into master because you're reasonably confident you can then go and deploy that. The way it works in GitHub is that every continuous build tool, every continuous integration tool can actually write what's called a status into the pull request. And that's done through some APIs and events management, which I'm going to cover later. But we can see here that we've got two builds that have succeeded. A build that's happened because of a branch change and a build that's happened because of a commit to a pull request. Now those builds have succeeded, so in a lot of cases people will just go simply deploy that code into production. But there's another continuous integration tool that's running here called OpenCover. Has everyone heard of OpenCover? So OpenCover is a tool that allows you, when you run unit tests, to pull back reports from those unit tests on how much of your code base was actually covered by those unit tests. So we can see here that there is a required 90% coverage of the code base. Sorry, the code base is meant to be covered by unit tests for at least 90% of that code base. And so we have an actual policy here in place that's not necessarily technical, but a requirement that the code base, 90% of the code base, has been run through a unit testing mechanism before we'll let it merge into production. So in this case here, even though our builds succeeded, there's 17% of the code that actually hasn't been tested, and that could contain the bad stuff. And the way we can do that is we have a very extensive API. So even if the integrations that you're looking for aren't necessarily on the market, it's quite possible to write your own. It's all REST-based. We have plenty of projects actually on github.com for integration into .NET, Swift if you're an Apple developer, all kinds of development environments that allow you to actually write your own tools to sit on top of GitHub, as well as build your own integrations if you've got any in-house developed continuous integration tools. Some other things that then come in handy, and this one's an important one here, is the idea of an issue. Now, this issue is actually something that we're going to cover in our demonstration later on. But the idea around issues is how you then start the discussion around codes, features and fixes that need to be put in place when nobody's actually started writing code yet. And you can do things like integrate it into any of your sprint or other agile methodologies using things like the milestones and the signees and labels and so forth. This particular one's important because the demo is going to cover a bookstore for a web application. Projects is something that we announced at GitHub Universe in September last year. If those of you who are familiar with Kanban type project management, we bring you a very lightweight mechanism here. You can probably put in notes, convert those notes to issues, basically have as many columns as you like that are named in any way, whatever makes sense for your organization. I'm not here to do a sales pitch. So here's an example, for the Visual Studio Code project, where they had a bit of a test run to see what they could do with projects not long after we announced it. Does anyone here already use the GitHub integration with Visual Studio? All right, because it actually ships with Visual Studio itself. So you can, if you do a customize install, you can actually click on customize, pick the GitHub extension for Visual Studio, and away you go, it's already installed. If you don't already have it installed, you can download it from that web address. Don't write it down because everybody gets access for these slides, so don't worry about it too much. All right, so let's do a little bit of a demo now. And like I said, I'm going to talk to a recording here. Sorry? Nope. Works with both .com and the on-premises version, GitHub. I call it on-prem, but it can be hosted on Azure, for example, as well. All right, so this is our web store. It's a bookstore. It's going to knock all the major electronic bookstores off the planet. But one of the feedback that we've got from people is that there's no way that they can look at ratings, how people have been rating those books, whether or not they're actually useful to buy or not. And that was actually then covered in that issue that I showed you earlier. So what we have is we have here Visual Studio. I go into my Team Explorer and you can see that I've got a plugin for the Team Foundation server as well as GitHub. At this point here, I can go and connect. Now, if I want to connect to github.com and I don't have an account, I can actually just go and click on the link, sign up, and then come back in here and connect. Now, in this case, we're actually connecting to a separate GitHub instance. So, because you can run GitHub not only github.com, which is our service that runs out of the US, but you can have your own private instance that runs, for example, on Azure. So we've connected in, and you can see now what's available to me is I can clone a repository that's already existent on our GitHub instance, or I can create one. And what we're going to do is we're going to clone the project because it already is there. We just got to make some changes to it. So let's go and do that. So I click on clone, and it's now going to give me access to all the repositories I have available. So this is the reading time demo, the one we're going to do. I find a path locally that I want to place it, and then I click on clone. It goes off, grabs all the objects it needs, brings down the master branch, and away you go from there. On the left-hand side, you can see any output from any command line tools. So this is a really great spot to troubleshoot things when stuff goes wrong. And down on that bottom right, we'll see things like, here's the repository that we're working in, and currently we're working within the master branch. So now I've gone in and I've opened that local copy of the repository, and I've clicked on the actual solution. Now, at the moment, everything you're doing here is very Visual Studio Code centric, right? I've double-clicked on the solution, and I'm now browsing through the code that's sitting within that solution. And you can see here now, this is the code for our book. I don't have any methods or variables at the moment to deal with that rating set, and that's what we're going to add as part of this. Please ask questions at any time. I can quite easily stop this. So the first thing I need to do is I've got to go down and make a branch, because remember, we're not going to be committing directly to master. So I'm going to create a branch, and I usually do it by my username and then the feature that I'm adding. So you can see that it's Afray add ratings. I pick the branch that I'm making the copy of. And you can see there now it's made a copy of the branch, and it highlights with bold to say, okay, this is now the branch that we're working in. Now that wasn't sped up video. One of the good things about creating branches in Git, it's instantaneous. It's not like you've got to wait 25 minutes for all the files to copy or anything like that. So I'm a terrible typist, so eventually I get to type 3 lines of code or whatever it is. We now have our variables and our methods in there. So you can see we've got a rating, and we've got some getters and setters. The smart ones amongst you, or the eagle-eyed ones amongst you, will realize that there is an error there, and we'll go back and we'll pick up on that error soon. So I've made a whole bunch of changes to code. If I just click on the changes button, I can see what I've added is I've updated my models, I've updated the actual view model for the book, and I've added an image to represent the star. So now what I want to do is actually commit those changes, because at the moment they're just sitting in a staging area ready to go. So I've done a quick message to say, this is what I've done, I've added the ratings feature, and now those changes are now committed to my branch sitting locally on my machine. But I haven't pushed them back up to github.com yet. And that's where that sync button or that little sync link comes into play there. So I click on sync, and it's going to take me to the synchronization page. Now, if I was interested in getting stuff coming down, then I'd either click on the fetch or the pull button. If the branch was already existing, I would click on the push button because I'm pushing my changes to the branch. But we don't have one there, so I clicked on the publish button to go and create that branch remotely on github.com and push all my files back up into github.com. And as you can see, this has all happened from within Visual Studio, right? It's not like you've got to wander around somewhere else. If you want to do this at command line, you can. But we'd like to, we know that people work within this environment, so you should be able to stay in this environment as much as you want. Yep.
With Visual Studio 2012, we found the Git integration a bit buggy, especially if you also change files outside of the IDE.
Yep.
Start to raise exceptions.
Yep.
Has that been improved?
Everything you're seeing here is in 2015,
Yeah.
and we've taken advantage of a lot of things in 2015 to improve upon that. Yeah, but I know where you're coming from. My recommendation for Visual Studio is always use the latest one that's around. I've tested this with the release candidate of 2017, but I didn't get a chance to record it in time for this demonstration. Fair enough. My suggestion there is download the community edition and have a play and see whether or not it'll do it from there on in. Yeah. Fair enough. Where was I? Okay, so what I want to do now is I actually want to open a pull request. I've made several more changes to my code, and now what I want to do is actually go make it available for discussion. So I've clicked on the new pull request button, and you can see that it's actually used a template for me to fill in. So I put in the number of the issue that I'm fixing, and just list a few of the things that I've done, along with the request to say, hey, I'm ready to review and discuss this when you guys are. Those templates are also used within the GitHub web environment, so whether or not I'm doing that from a browser or I'm doing it from here in Visual Studio, I'm getting the same form to fill in. I've now created my pull request, and let's go and have a look, see what happens over on GitHub. I get an immediate link straight through to the browser from Visual Studio itself. And you can see here that here's the original message that I put into place. Here are some more commits that I've made. But here's our continuous build environment, and it's failed completely across the board. Well, actually, 2 of them have failed, and the third one is pending. And the third one is the open cover, which checks our unit test to see how much the code base was covered. The problem with that is it never got that far because the test never run. If I click on a link, it takes me directly to AppVeyor, which is our continuous build environment. I can scroll down, I can see that we ran a .NET info command, we restored our build environment. We then actually did our build. Now, we did a verbose build so that we can make sure we could actually look at as much information as we possibly can. And then we've got all this red line stuff at the bottom. And it's actually told us that we can't implicitly convert a long to an int. All right, so that's where our problem is. That's where our build failed. Now, remember that GitHub is a collaborative environment, right? So I've now logged in. Somebody else called Afdan has logged in and seen that pull request. And they've seen things that have gone on, and they've seen that the build has failed. Now, they can go and look at every individual commit, but that's not necessarily the right thing to do. So what they're doing here is they're actually looking at the actual file changes, and they've picked up the fact that we've declared it as a long, but our methods are actually working with ins. So I can then actually put some code directly within the a comment directly within that code there to say, hey, this should be an int, not a long. Add that comment, and eventually go back to my pull request. This is where I get to breathe for a sec. Go down. And we can see that we've got an inline comment of the code sitting directly within the conversation that's happening around the pull request itself. which is great because when Afray, the original writer, logs in, they can see that stuff and they can go in and make those changes. So here we are. I've gone and made the changes. I've now made it an int instead of a, excuse me, instead of a long. And I've pushed those changes up, and we'll now have a look what's happened at the pull request. Well, great. Our builds succeed, our unit tests have succeeded, but our coverage has failed because you haven't actually written the unit tests that are required to test that new code that we've put in. So I'm still not allowed to merge this code and put it into production. Afdan's been very generous and said, hey, you might want to put some unit tests here because we're trying to help each other out. And this is where I'm going to step back from the demo. I'm going to talk to you a little bit about how the AppVeyor part of it works. So there are two files. There's the YAML file, where we actually describe what to do for each step of the build to AppVeyor. Then we also have a module file that we can actually use to write our own scripts, our own methods to be able to be pulled in by AppVeyor and used whenever needed. So for example, we can do things like tell AppVeyor that we're running Visual Studio 2015. So when it goes to know the build, that's the environment it's going to use. Excuse me. Next thing we do is go, okay, what do we want to do before the build? Well, we want to import that module, and then we want to run a function, we want to call a script that's sitting inside that module called invoke pending status. And what that does is it sets GitHub, the pull request in GitHub, the status of it to be not complete, so that nobody can actually go ahead and merge that, the branch into master branch. Then there's our build script, and we know that we got about 3/5 of the way through that. We did a not in info, we restored our build environment, and then we ran the verbose build. That failed, so the other two things didn't run. I won't get stuck into this too much, but I want to give you an idea of what the scripts look like. So for example, the invoke pending status script here simply calls a thing called update GitHub status with a message saying pending, waiting for open cover to complete. That actual method, update GitHub status, is defined within here itself. And it's a bunch of scripts where we've actually written where we build from the API. Firstly, we get past a couple of things like what the status is meant to be and what the message is. We pull some stuff out of the environmental variables, like what repository you're working with at the moment. What's the commit? What's the actual commit that we're working with right now? Sorry? Yes. And the other thing that we've got here is you can probably see a GitHub token. That's an authentication token, all right? So to allow AppVeyor to actually log in, pull out the files when it needs to, or in this case here, make a GitHub call to stop the merge from going ahead. The rest of it is simply we're building a REST call. So we've got some data here that we're sending that'll be sent as a JSON bundle, and then we've also got the parameters which basically provide the APIs that we're calling, the method that we're doing, which is a post, the headers that we need that also happens to include the token, and the content that we're actually passing on is a JSON. We convert that data into a JSON and send it on. The only other one to be aware of, and this is one where you've got, and don't worry about the amount of code and variables and stuff that's sitting here, but this is where you can invoke scripts to be able to work with any of the custom tools that you may have in place. So for example, this is one here. We build a whole bunch of information around what are we looking for in our unit tests in terms of code coverage and so forth, where we want that information to be stored. We run a report generator that looks at how much of that code was covered by a unit test, and we store that information somewhere. Finally, we go back down and use the set report status to send another message back to GitHub about whether or not that fail has succeeded. All right. Any questions about that? I don't want people to get too hooked up in the code. I just wanted you to understand that you can build your own custom build and tool environments here. Yeah, sorry.
How much of this is provided as a skeleton by GitHub?
We don't provide that ourselves, but my email address will be on the last slide. I'm quite happy to share this with you if you like from there on in. A lot of this is a function of an external system that integrates with GitHub. So they have all this on their site, but I'm quite happy to give you this as an example if you like. Yeah, sure, not a problem. The question was, how much is this provided by a skeleton, as a skeleton by GitHub? If you search on our site, for example, if you go to github.com and search for AppVeyor samples, you'll probably find stuff that's there because people share this all over the place. I'm more than happy, though, to send you these scripts if you want to use that as a start. Not a problem. Yes.
The line that's testing for the percentage there, it seems a bit brittle because that's very technology specific as to what's going to come out of the unit test run. Is there any other solution in the future where the coverage will be more clearer by some other object coming out of the
That's not what we provide. This is integrating in with other tools. So we don't provide this bit. This, like, for example, the OpenCover stuff is part of the, is actually run on the AppVeyor server, not from us. So the idea being is this is meant to be a relatively simple example to give you an idea how it happens. You can build much more robust reporting if you need to do that around that. Or there's plenty of other tools out there that do much more robust reporting. And again, you can write stuff to integrate with that. I'm showing what you can do. This is not something we actually give away. That's kind of hooks into that question there as well. Awesome. So you can see here now that I've actually gone in and we've written some unit tests. All right. And what I want to do now is then commit those unit tests. So we'll do the same thing as we did before. There's my terrible typing. All right. Now, instead of doing commit all and then pushing, once you get used to this, we give you an option. So here, what I'm going to do here is I'm going to do a commit all and at the same time push all this back up to GitHub. Again, this is all happening within Visual Studio, except for those bits where we were looking at the conversation that was happening outside. So we now pull all that back up to GitHub. We go and have a look at our pull request. And as we scroll down, everything is now passed. Right? Because we've got our builds and our unit tests have passed, and now our code coverage is at 95%, and that button is now gone green. And then Afdan, a few moments later, says, hey, this is fantastic. Code coverage is 95%. Let's ship. So at that point there, I can go down and I can click on the merge pull request. We will take the message from the pull request to be the merge commit message. I do the merge, and we're good to go, and I can go delete that branch. Now, a lot of people ask me this one. You can restore that branch. The delete branch is only removing it from UI clutter. We still keep track of that branch. So you can always restore it if you need to at any particular time. So any questions about that so far? Yeah, look, and we don't kind of prescribe it one way or the other. If that works for you, that you go, okay, this is Afray's branch, or this is Afdan's branch, and he always works from there and in, that's fine. And in those situations there, what you would be doing is instead of deleting the branch upon the merge, you would just keep working on that branch. The thing to be aware of is if somebody else then goes and commits to master, you need to bring those changes back into your branch and then work in from there on in. Now, the thing that we also do at that point there is if there have been changes in master and you haven't brought those changes into your branch, when you actually go to merge, we're going to, no. There's some merge conflicts here, there have been changes that have happened. Now, normally that used to require you'd have to pull everything down onto your system, your laptop or wherever it is, and deal with those merges locally using various tools that are out there. We've started to bring in merge fixes in browser. So right now there's a very simple, straightforward merge tool in browser itself, so you can handle your merges there. We're also doing some work around semantic merging, so that instead of doing things like distance, we do a lot of stuff now around the distance that the changes are apart in a file and stuff like that. We're getting a lot smarter than that, so that we can automatically merge things without committing to destroying production environments. That we can do a lot more automatic merging if required. So what happens is, it's a good question, and I'll summarize it just quickly. So let's say, for example, that you've got a master branch, and everybody's gone off and done their individual feature branches, and then they're now all trying to merge. And everything worked fine while they're sitting out here, but the merge become a bit of a mess? So what will happen is, we're kind of smart enough to kind of understand, firstly, that somebody's going to merge. All right? If there's a conflict because somebody's merged before them, they have to resolve those conflicts and then move on from there. We've had that work at a pretty big scale. We're just trying to smarten up the process a little bit more from there on in. Yeah. that will actually become apparent in the actual conflict, because you won't be able to merge until you pull those changes have been checked in, right? It'll be running through a continuous build, and if your stuff has broken it, it'll pop up in your build from there on in. Does that make sense? Did everyone get that? Cool. All right.
So is it just about the conflicts at the check-in time, or is it going to tell you there are changes and you need to test those changes first, irrespective of whether it's conflicts or not?
Because those changes have happened and it's been merged in, we consider those to be conflicts as well. Even if they're working files, like even if that stuff is now working fine, which it should be because it's in master, if we perceive that conflict, and for a conflict doesn't necessarily mean that this will break that, it's just that you guys have made changes a little bit too close here, you need to sort that out before you merge that in. It's not necessarily for a broken piece of code. Yep, and that's why you have the continuous automation processes happening here to do your builds and your integrations, right? Because it's the same thing that's running every time. We do 100 releases a day on average into github.com using the very same stuff we're talking about here. Don't get stuck on that number, and I'll cover why in a second. All right.
Possibly a naive and off-topic question. I noticed you had an image in there. If you have a lot of images / other binary sort of objects, what are your recommendations?
All right, so that used to be a problem with Git for quite some time. There is now a project out there called Git LFS. All right. For those of you who've ever worked in the SharePoint world, SharePoint used to store documents inside the database, right? Remember what indexing was like? It was awful. I come from document management, right? And SharePoint was a competitor. They brought in something not very long ago, whereas instead of storing the actual file in the database, the file is stored out in storage, and it's just a reference to it sitting in the database. That's essentially how Git LFS works for Git as well. So instead of saying, okay, I'm going to store the Git file and all the stuff, all the information around in the database, because there is some stuff stored in databases, we push that off to the side, and we only just put in like a UID in the appropriate field inside of Git, which means that when indexing goes on, for example, or diffs type stuff goes on, Git's not struggling to do that with binary files. That's what drags Git to a screaming halt. Microsoft has also done a whole bunch of stuff that they're about to release into Git as well to really enhance how it handles large files. At GitHub, we actually employ engineers who are active contributors to the open source projects that sit in underneath. So a lot of people that work for GitHub actively contribute to Git, actively contribute to Git LFS. So we put a lot of things in there as well to help us deliver a better service on top of Git. See, that's not a naive question.
I guess, but so Git LFS just happens, or it's something you need to add in or something? Or?
It's now pretty much distributed with Git. There are some configurations you do because you've got to tell it where you want it to store the binary files and things like that.
So research that and it should be good. That's the way to go.
Yep. And look, there are things like package managers as well. Things like Artifactory. I always screw that name up. So Artifactory, for example, it's designed to handle things like packages, installer packages, and so forth, and take them out of the Git repository. Which one's the right solution for you? Depends on what your needs are. That's all right. So automatically deploy to Azure. I don't have a demo for this. The reason being is at the moment we merged it, it deployed straight away. All right, and there's nothing to really show. All I do is go back to a web page and reload it. So I'm going to talk a little bit about the technology behind that. How are we doing for time? Awesome. All right. So this is where we're at our point. So we've made our branch, we've had our conversation. Sorry, opened our pull request, had our conversations, used our continuous integration tools to do our testing, make sure our code coverage is correct, everything's going from there. And we've now put the code back into our master branch, and we want to get that across to Azure. So how do we actually go ahead and do that? So this is a web application. So this is Azure's web applications console. So we have an application called Sample, and we're looking at a deployment options. At this point here, we're looking at what is the source for the application. And you can see we've got things like Visual Studio Team Services and a few others. I probably should have blurred the one underneath GitHub, but I've got friends there, so I won't do that. So one of those options is GitHub. And if you select GitHub from that list, Basically, it provides some authentication information so that you're giving Azure permission to go in and pull the data, pull the files from the repository. What project? In our terms, that's what repository. For the demonstration, that's reading time demo. The branch that we're working from, the branch that we want to deploy, in this case, it's the master branch. Doesn't have to be, and I'll go into that in a second. And then you can set some things around performance testing and so forth. Once I set that up, and I provide the authentication information, the actual Azure system will now go and log into GitHub and it'll register what's called a webhook. And this is one of the things that for me really gets it for GitHub, in that, like I said earlier, if you're not using something like GitHub, you have to poll the repository every so often because you've got to do a pull and see if there's changes and do that. The problem is that slows down things like Git. Git doesn't like being asked to do stuff unless it has to do that. So we built some tools upon that around event reporting. So we know when somebody makes a change to a branch. We know when somebody creates a user within the repository. We know when a branch has been merged into another branch. And applications can register to be notified of those events. They provide a URL, and you can see the first one is our AppVeyor integration, and it was interested in pull requests and pushes. Whenever a pull request was raised or a commit was made to a pull request, a push, whenever somebody actually pushed something up from their machine into the, into the GitHub repository. The second one was placed there by Azure. So Azure's logged in, and they've said, okay, whenever somebody has made a push, let me know. And what happens is we take that URL, in this case it's here, it's readingtime.scm.azurewebsites.net/deploy, and we send that a message includes a JSON payload of what the event actually was. Azure will look at that and go, okay, that's a master branch has changed, I'm interested in that. It will then go, it knows how to pull the stuff off github.com because that's what the plugin does, and deploys it. All right, so the minute I click merge, and that became part of the master branch, Azure hopped in, took a copy of my files, and redeployed that application. If now the URL that you see there, the one that I've got actually within the screenshot, is for a public repository. If it's a private repository, you can see a whole blurred bunch of keys that's put in there as well. That's just done for extra security because it is a private repository. The screenshot you see at the bottom is actually a log sitting within the Azure website deployment platform, dashboard. So what's happened here is instead of Azure asking every 5 minutes, has it changed, has it changed, has it changed, we've sent it a message, it's come in, got the information it's needed, gone, great, I'm interested in deploying master, grabbed master and deployed it. I've spent way more time talking about it than it actually takes to do. Any questions about that? It's something I just cannot demo because it happens so quickly. So here's our application with our ratings built in. Now, everything I've spoken about is assuming that you're deploying when you merge back into master, but we do things at GitHub a little bit differently. What happens is we get to the point where everything's been approved, we've been given the shipping approval, and we actually go and deploy from that branch. And we use feature flagging to slowly roll that out amongst our customer base. Once we're happy with that, we've dealt with all the issues that popped up, a lot of quick fixes, things like that, 100 deploys a day, we then merge it into master. If during the course of our branch deployment, we notice a major issue, we can always roll back to that master because we know that master is already stable at that point and is working. If, however, like I said, we don't notice those problems, that's when we merge into master. This allows us to actually do multiple branch deploys at the same time. So I might log in and I might get a new feature that's been ramped up slowly, but my friend here may not. He may get a totally different feature that I haven't seen yet. All right? And then eventually, as we get happy with it, we expose those features to more and more customers, and then it becomes one big, glorious github.com. That's okay, because we can support that as well. So we do auditing and reporting about who's deployed what and to where. And this means that you can bring the tools that you want to use into play at that point here. So for example, this is Slack, which is our chat client. You can see here that I've logged into Slack and I'm having a conversation with somebody called Hubot. And I've asked Hubot, where can I deploy? And Hubot's gone, hey, you can't deploy, you've got to sign in first. All right, so I left that there because what I did was to show you that this is a secure environment. It's not like somebody can just hop onto my Slack channel and start deploying. So I've signed in, Hubot's happy and said to Hubot, okay, where can I deploy? And here are all our various environments that we have at github.com that we can deploy in. So production, obviously, at the moment, somebody is running a branch in production that they're testing in the way I spoke about before with a branch-based deployment. There's a whole bunch of other environments I can use there. So for example, Slowtown is the production environment that we use when we want to test for people who might be accessing from systems that haven't been connected to the NBN yet, for example. All right, high latency connections. We have various different environments that we can use to simulate how our customers interact with GitHub. And nobody's in the queue, which means that as soon as Josh has finished testing the JQ Novell branch, I can actually go and deploy into production. Hubot is an automated chatbot. Has anyone here used Hubot or heard of Hubot? So Hubot is something that we've produced that we give away. Go to hubot.github.com. And Hubot has integrations. There's 1,500 projects, node packages that are basically designed for interaction with Hubot, all built by the community. Hubot is a Node.js application, which means it's extensible using JavaScript or CoffeeScript, so fairly straightforward. We actually teach our sales guys how to write their own scripts for Hubot to do things like automate their quoting processes and so forth. And you can get Hubot to do all kinds of things. So for example, I've said to Hubot, okay, give me a graph of all the deploys that have happened in the last 30 days. Well, this was for January of this year. And Hubot will give me a graph, which we'll zoom in on now. And there's a couple of things I want to point out with this graph. Firstly, it's got the word deprecated on it because we've just changed our internal visualization tools and I haven't had a chance to sit down and learn the new ones yet. So I'm being warned I need to get off this one pretty quickly. The second one is that this is a graph of deploys and it's always upwards and to the right, which most of your managers probably would love to see. All right, so these data basically says that here over January, we did on average 50 deployments a day. I ran this script, like I said, I think August last year for a conference, it was over 100 a day. And a lot of organizations get focused on that number, and I said, be very careful about that. Because everything I've spoken to you about today is not about reaching that number. All right? This is a consequence of doing those things. It shouldn't be the goal of doing those things. All right? Because at the end of the day, this is about looking after you guys as developers. It's about looking after your operators to make sure that you don't live and work in a toxic environment. Fix those problems and this stuff will happen as a matter of course. So if you kind of recall in the late 90s, did anyone here ever hear of something called the bastard operator from hell? All right. It was funny, wasn't it? All right, the whole idea was to bring to a head the problems that exist between developers and operators. All right, developers were always there. They were pressured to bring in the latest features as quickly as possible and get them out there. Operators were given the exact opposite job. They were given to the job of saying no, to keep everything up, to keep everything stable. All right? And the bastard operator from hell was designed to actually say, you know what? This is a ridiculous concept. We've got to do something better about it. The problem that happened is that too many operators took it seriously and became a mantra, so things got even worse for a while. And then what happened was about 9 years ago at a conference, guys from Flickr hopped up and they did a presentation that said 10 plus deploys a day. And there was a subtitle underneath that, but everybody hooked onto the 10 plus deployments a day. And that became, oh my God, that's what we've got to do. We've got to get to 10 plus deployments a day. The subtitle of that presentation, in fact, the focus of that presentation was Developer and Operator Cooperation at Flickr. And that's what changed things for them. Right? And those guys were groundbreakers in the DevOps movement. So if people come to you and go, we've got to get up to 50 or 100 deployments a day or anything like that, and that's what you focus on as a target, the things I speak to you about here may not actually succeed because the numbers are too much of a pressure. The idea being is to take everything that we do, everything that we talk about, the open collaboration, the automation to make things run smoother for you, and you will get the right number of deployments a day. It may only be one a day, but if that works for you guys and makes everyone happier, that's where it's meant to be. All right. Sorry? There might not be bugs to fix. But if your boss is on your back because you haven't done 50 deployments today, what are you going to say? So my suggestion to you is as you embark on this journey is to not worry about the number of deploys that you do. It's about working with your culture. It's about working with the people that you've got to work with on a day-to-day basis. Work with your operators and just make life better. So this is Hubot. Like I said, Hubot is a Node.js application. This is Hubot's website. Go in there and have a look. See, there's plenty of integrations for plenty of tools that are out there. We use things to go and do search Google Maps for addresses. We basically live inside our chat client. But Hubot can really help here in terms of working in a continuous improvement and build environment. Let's say, for example, that you deploy an application and something goes wrong. Hubot will notice that there is a problem with the performance. It will go and open up an issue in GitHub. It will go query whatever performance tools you have to build graphs, drop those inside the issue, and give you all the information you need in one spot, instead of you having to go and hit a whole bunch of different tools. You'll need all those different tools, but you need something to glue all together. So it's Visual Studio, GitHub and Azure. Visual Studio, use the environment that you already know about. Create your branches, add commits, do all the pull requests that you do with Git and GitHub, but do it from within inside Visual Studio itself so that you can keep working. Come across to GitHub when you want to start sharing and discussing your work. All right, go through your code review processes. Hook that into your continuous build environments. And then finally use Azure to deploy your applications fast and quick and get up there. Cool. So this is a tweet from Microsoft themselves, so I'm not lying. They basically say that what they're now done by using over to GitHub and using some of the things we've spoken about here, 10 times the productivity, 10 times the fun. So thanks. This is a placeholder for another slide, but they didn't take this one out. I don't know why. Continue your learning path. So you've probably seen all these slides before. Fill in your form so you can get your drone or your drone pilot pass. I'd rather have the drone. And thanks. That's my email address. That's a real email address. That's me. It's afray@github.com. I'm more than happy to take emails and answer and things and have chats and stuff like that. And we've got some time for some questions. Oh, it all works. Thanks. Awesome. Person down the back. Sorry, yep. All right, so that's an internal politics question, but I know exactly where you're coming from. They've given you more work to fix. You've opened a pull request because you had a specific bunch of stuff that you were working on. They've gone, hey, they've got this bug. While you're at it, fix this as well. Correct? All right. So my philosophy on that, it's a personal opinion, it's not a GitHub recommendation, is the pull request should be brought to a close as is. So that could be a rejection, and you go back to square one and do some bits again, or whatever you've got to do at that point. But if those of you who have ever been involved with a software project, you've got to fix this bug and then do that and do that and do that. Well, adds to either feature bloat, bad discussions around what's happened, incomplete work, and things like that. My suggestion personally is I would bring the thing that you're working on to a clear finish and then see what you can do from there on in. So get what you've got working and then fixed, all right? Once you've done that, if that's working fine, merge it, depending on what your workflow is here, right? I'm assuming, right? And then do another branch to do that. I think that's a safer mechanism. Or if you're happy with all the stuff that you've done up until now, there's nothing stopping you from making additional commits because each one of them will then trigger more unit tests and stuff like that happening. All right. I can't answer it any better than that. Yeah, sorry. Another way you can do this, gets a bit sneaky, is get them to open up another issue and then discuss it within that issue and then push that off to the side, finish what you're working on now, and then start working on from there. That's what we work a lot in GitHub internally. We have, for example, we have things like a repository for the legal team, a repository for the HR team. I can tell you one of the scariest things is to have a lawyer tell you to open an issue in the legal repository, because they use all these GitHub terms, but they're just, all we're trying to do is get a contract change, for example. And that gets used a lot inside of GitHub. You're working here or you're working on something, and someone says you want to add that to it, we say open another issue, and we keep that as a separate discussion. It requires a little bit of bravery on your part. Anything else? You're all happy. You all want to go do this thing. So thank you very much, everyone. I tried to avoid the sales pitch, but hopefully you got some interesting info out of it. I think you guys have got a party tonight now. Is that right? Tomorrow night, is it? I've got to fly back tomorrow. Darn. Please take my address. More than happy to have a chat with anyone over email about things. Thank you.